Sections on 4.6 related rates. So now we're doing the application of the derivative. So in this problem right here, it says a police cruiser is approaching a right angle intersection from the north, is chasing a speeding car, and that has turned the corner and is now moving straight east. So when the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east with the radar, it is determined that the car is increasing at 20 miles per hour if the cruiser is moving at 60 miles per hour. So what is the speed? So let's go ahead and talk about then the information that we need for this. So I have then is the north, south, and the east and west kind of laid out right there for us. So does everyone know about the never eat shredded wheats, right? That's how we're going to do the rotation for that part right there. And then we have is the police car right there. I called it a P, so that's a little police car. And then this is the car that's running away right there. So that's going to be the C right there. So from the information that we have that the cruiser is 0.6 miles north of the intersection. So the cruiser or the police car is 0.6 miles, so I have Y is equal to 0.6. And then the car is 0.8 miles to the east, right? So this is the car that's going 0.8 miles east. So this is east right there, so that's why I knew it's going to be on this side right there. And it is determined that the car is increasing at 20 miles per hour. So increasing has to deal with then the speed, which is also then first derivative, which we can also talk about is the velocity, right? Especially if the unit is miles per hour, then you know you took the first derivative right there. So that's why right here we're going to look for is the speed. So this is speed right there. So speed is 20 miles per hour. And also the cruiser, which is the police car, is going 60 miles per hour. So 60 miles per hour is this part right here, the dy over dt. And then, so let's also mention about the derivative. So when you have a y and when you're taking the derivative of y, it's going to be now dy over dt. It's similar to the implicit derivative that we did, but instead of dy over dx, it's going to be dt for all of them because we're talking about time as the respect right there. So that's why you get the 60 miles per hour because of the time right there. Okay, and so this is S. I'm going to call it S. And so this right here becomes ds over dt. And since this is x, this is the dx over dt right there. And so they're asking for is what is the speed of the car? So that's this part right here, which we don't know. Okay, so I have information that's laid out. And we want to also point out it's a 90 degrees right angle right there because then I can always use sine, cosine, tangent, and also use the Pythagorean theorem. So I just need is to find out this right here. Since it's a right triangle, I can use Pythagorean theorem to find out what S is right there. Okay, so let's go ahead and do that. So Pythagorean theorem says it's going to be what, x squared plus y squared, and I'm going to call it S squared because that's the slope or the hypotenuse that we're going to use. So then I have then the x we know is 0.8 squared plus the y we know is going to be 0.6 squared, right, equals S squared. And if you calculate this out right there, the squares, it comes out to 1 is equal to S squared. So square root of 1 is just basically 1. So S is equal to 1 right there. So that's the information I have right there. Okay. So now I have to figure out is what is the dx over dt right there. So using the Pythagorean theorem now, we're going to take the derivative of this because I need to somehow get this dx over dt, ds over dt, and dy over dt introduced. And the only way we're going to introduce that is through the derivative. So using then is this part right here. So I'm going to rewrite this right here. X squared plus y squared is equal to S squared. And we're going to take the derivative. So it's just a simple power rule. I bring the 2 down right there. That becomes 2x. Since I took the derivative of x, this becomes dx over dt. It's similar to the implicit rule that we did, right? So then plus, do the same thing. We bring the 2 down right there. We get 2y dy over dt. And so notice it's all over dt because it's respect of time is equal to 2s and then ds over dt. Okay, so now let's substitute in numbers. So I know then the x number is 0.8, right, because that's given right there. I know dx dt. No, I don't actually know that because that's what I'm looking for. So we'll leave that alone, and I'll box that because that's the answer that we're going to get to at the end, is plus, And then we have is 2y, so we know what y is because y is 0.6 right there. So 0.6, I know what dy over dt is because that's the negative 60 up there. So that's the negative 60 over here, negative 60. And equals 2, and I know s is equal to 1 because that was just calculated right there. So 1, and ds dt is 20, so we have this 20 right there. Okay, so then begins the algebra because we just want to find out is what is dx over dt. So if you do the calculation and you bring this over on the other side, that should work out. So let's just calculate this. I'm going to go ahead and do that on my calculator. Let's do 2 times 0.8, we know is going to be what, 1.6? So 1.6 dx over dt is what I'm looking for still, so I'm going to box that right there. And then plus 2 times, so let's see, 2 times, where's my times here? Times 0.6, and then times a negative, so I'm just going to have to put parentheses, negative 60 in there. So that's going to give us negative 72. Okay, so then negative 72 right here, so negative 72 equals, and then let's see, 2 times 20 gives us 40, so we put the 40 over here. So we're going to bring the negative 72 over on the other side of the equal sign, right? That's going to give us about 1, let's see, dx over dt is equal to 112, and then we're going to do 112 divided by 1.6, right? 1.6, let me just check just to make sure. So 40 plus the 72 gives us 112, yes. And if we divide it by 1.6, so divided by 1.6, that gives us 70. Okay, so dx over dt is equal to 70. dx over dt is equal to 70. Okay, so that's your final answer for the speed of the car. All right, now let's do the next one. So the next one is about a hot air balloon. So a hot air balloon is rising straight from the level ground, is tracked by a rangefinder, which is 500 feet from the liftoff point. And at that moment, the rangefinder's intersection or the elevation of angle is pi over 4, and the angle is increasing at the rate of 0.14 radians per minute. How fast is the balloon rising at that moment? Okay, so then we're looking for is information. So what information do we have? I have 500 feet. It says from the range pad to the liftoff. So I believe this is going to be then our x is equal to 500, right? And then we know that theta is going to be pi over 4. So I have this theta right here. Oops, pi over 4. Then I also know that the angle is increasing at the rate of. So since the angle is increasing, we're going to say then d theta, right? So d theta is over dt, because that's the rate now, of 0.14. So that's the angle that's increasing at 0.14. And is there any other information that I have? Let's see. Okay, so that's about it. So then from there, I probably want to find out is what is the height of this, right? So this is now, again, this is a right angle right here. So then I can use is from here, theta is opposite over adjacent. So opposite over adjacent is tangent. So I'm going to set this up as a tangent problem. Tangent of pi over 4 is equal to the height, which we don't know, all over 500, which we do know, right? So then from here, I just put that in the calculator and work it out. So let me see. Oh, actually, pi over 4, let's do a special triangle pi over 4. So pi over 4 is 1 square root of 2, right? So theta right there. And so tangent is going to be opposite over adjacent. So all of that is actually 1 right there. So it's going to be 1 equals h over 500. So h is obviously equal to 500. Okay, great. So we know h is equal to 500. So again, the question is asking us then to find what? What are we looking for? It says how fast is the balloon rising at that moment? So balloon is rising from the ground up right here. So we're looking for is dh over dt. Okay, so that's the question mark right there. So this is one of the special cases. So there's two formulas you'll use. You use either the Pythagorean theorem or this one right here, which is then the tangent equation. So the tangent equation then we have was that opposite over adjacent again that we're going to use. So I'm going to set this up as a tangent problem. So tangent of theta, which is that pi over 4 we know, is equal to h, right? Actually, let me just put theta right there. So tangent of theta is equal to h over x right there. Okay? So I'm calling this h right there, so that's the opposite over adjacent, which is the x right there. Okay? So now from there, you don't want to put all the information in, because what you want to do is now take the derivative of this, because we want to find is dh over dt. And the only way you're going to get dh over dt introduced is if you take a derivative of this part right here. Okay? So I know then the x is equal to 500, so I'm going to go ahead and put 500 into that. So equals h over 500. And if I now substitute in theta, what's going to happen is then I'm going to find out what h is, and then that's not going to help me because I need to find out the derivative of h, okay? So this is the information that we're going to have. We're just going to put in 500. So I'm going to bring the 500 to the other side right here, right, because it's like all over 1, and you're just cross-multiplying right there, cross-multiply, cross-multiply. So then we have this 500 tangent of theta is equal to h. And then now we want to start taking the derivative, so that way we can introduce the dh's. So 500 is a number, so we're going to copy this right here. Derivative of tangent is secant squared, right, because that's our sexy squared. And then because I took a derivative of theta, that's going to introduce that d theta over dt is equal to derivative of h is now dh over dt. Okay? So this is like the x, right? If I take the derivative of that, it just disappears. So, but I do have still that dh over dt. So now we can substitute in more numbers to figure out what the dh over dt is right there. So I know theta is pi over 4. So I'm going to put in 500 secant squared of pi over 4. And I also know d theta over dt, right? Because that was given right here at 0.14 right there. So 0.14. And this is still, we're looking for dh over dt. Okay, so now with the secant right there, let's go ahead and start separating that. So I have this 500 on the top times the 0.14, right, on the top. And then the secant, if I bring it down, this is going to become cosine squared of pi over 4. Okay? Because secant, remember, is 1 over cosine. So since secant is 1 over cosine, I'm going to bring the cosine on the bottom. Now, I can do this 45 off of this right here. Cosine then becomes adjacent over hypotenuse right there, right? So adjacent over hypotenuse. And let's go ahead and do that on the side right here. So then I have, again, is, well, actually, let's multiply that out. So the 500 times 0.4. So let's see, 500... So 500 times 0.14, and that's going to give us 70. So 500 times 0.14, 70. So 70 over the cosine, and that was going to be cosine squared. So we said then is 1 over square root of 2 squared, like that. Okay? So since this is a fraction, I can multiply the reciprocal, flip it up, so that becomes then 70 times the square root of 2 squared, right? Because that's 2 over 1 like that. Okay? And then square root of 2 squared, the square roots and the 2 will cancel each other out. So that's going to be then 70 times 2, which equals then 140. Okay? And so it's dh over dt, so that's probably miles per hour that we're dealing with as far as the units right there. Okay? So, again, let me just go over it quickly. So I have then is the Pythagorean theorem right there. We're going to use the Pythagorean theorem to solve for any piece of the triangle that we don't know. If you have all the information that's given, you pretty much should have only one piece that's missing. That's this part right here. Okay? Unless there's not enough information, then you can always put in 0, especially for the related part right there, the d something over dt. If that information is not given, you can actually substitute in 0. But you should have is 1 missing and 1 0 possibly and 1 given. and that should be enough information right there. So once we get that information, then since I'm looking for dx over dt, we're going to take the derivative of the Pythagorean theorem, so that the derivative becomes then 2x dx over dt plus 2y dy over dt equals 2s ds over dt, and then you do your substitution and then do the algebra to solve for that right there. Okay. Now, in special cases like this, where they actually give you angle instead, if they give you angle, you're always going to use tangent. So then from there, you're going to set up as a tangent problem. And again, if you don't have enough information, you can always use sine, cosine, tangent to solve for the missing piece right there. And then whatever is given then, so if I needed actually the dx right there, dx over dt, since I don't have that information, I would actually put in 0. So you can put in 0 for dx over dt since that's not given. But this is given and this is not given. That's what we're solving for. So we actually have enough information to solve for this piece right there. So with that, then when I set up as a tangent problem right there, equals h over x, because that's your opposite over adjacent. And I actually substitute an x of 500 right there, and then brought the 500 over to the other side. Then I took the derivative of this piece. So the derivative of a number, we just bring it down. Derivative of tangent becomes secant squared. And then from there, d theta over dt we introduce because we did theta right there. So d theta over dt equals. And then since this is h variable right there, we put in dh over dt. Then we did substitution. So we have is the theta is pi over 2. We know from here pi over 4. So that's your pi over 4 right there. And then we know d theta over dt is 0.14 because that's given right there. So that's the substitution right there. So then from there, I just multiplied 500 and 0.14, which is up here. And that came out to 70. And then from there, secant squared. Secant is 1 over cosine squared. So I just brought it to the bottom. Secant squared, and then using the special triangle. So anytime you have radians, you're going to have to work the special triangle out because most likely you're going to have a square root involved. So with that right there, cosine, then from the special triangle, cosine is adjacent over hypotenuse. So it's 1 over square root of 2. And I know some of you guys probably will ask the question is, but in pre-calculus, we never had a square root as a denominator. You can actually keep it for the moment right there and then just do your simplifying. Or you can simplify it by putting the square root up and do all that business there. Okay. So now from here, this is a fraction. So we did the reciprocal of that fraction, and that brought this up instead. And so now this is still squared. So when I take the square of a square root, they cancel each other out. Then you have it's a 2 right there. And so then 70 times 2 is 140. So that means the distance or the rate of this balloon going up, it's 140 miles per hour right there. Okay? So that is the section that we're going to work on for this right here.